3769. An airport's rotating beacon operated during daylight hours indicates A. There are obstructions on the airport. B. That weather at the airport located in Class D airspace is below basic VFR weather minimums. C. The air traffic control tower is not in operation. The correct answer is B. The rotating beacon at an airport is a visual signal used to convey important information to pilots and other personnel. When the rotating beacon operates during daylight hours, it serves as an indication that the weather conditions at the airport, particularly in Class D airspace, are below the basic visual flight rules, VFR, weather minimums. In Class D airspace, which typically surrounds airports with control towers, certain weather conditions need to be met for VFR operations to be conducted safely. These conditions include minimum visibility and cloud ceiling requirements. If the weather at the airport falls below these minimums, it is considered to be below basic VFR weather minimums. By activating the rotating beacon during daylight hours, the airport is signaling to pilots that the weather conditions do not meet the necessary criteria for VFR operations. This serves as a warning to pilots who may be considering flying into or out of the airport under VFR conditions that it may not be safe to do so. It's important for pilots to be aware of the meaning of the rotating beacon and understand the significance of its operation during daylight hours. It helps them make informed decisions regarding their flight plans and ensures the overall safety of operations at the airport. 3718. Airport taxiway edge lights are identified at night by A. White directional lights. B. Blue omnidirectional lights. C. Alternate red and green lights. The correct answer is B. Airport taxiway edge lights are used to provide visual guidance and delineation of the taxiway edges during nighttime operations. These lights help pilots navigate the taxiway network and maintain proper situational awareness. The taxiway edge lights are identified by blue omnidirectional lights. These lights are installed along the edges of the taxiway pavement, typically in a continuous row. The blue color helps distinguish them from other types of lights on the airport surface, such as runway lights or approach lighting systems. The blue omnidirectional lights emit light in all directions, ensuring that they are visible to pilots from various angles. This helps pilots identify the boundaries of the taxiway and maintain the correct path while taxiing. By following the alignment of the blue taxiway edge lights, pilots can stay on the designated taxiway and avoid encroaching onto adjacent areas. This promotes safe movement of aircraft on the airport surface and reduces the risk of runway incursions or collisions with other aircraft or objects. It is important for pilots to be familiar with the various lighting systems used at airports, including the identification and significance of taxiway edge lights. This knowledge contributes to effective taxi operations and enhances overall safety during nighttime operations. 3768. To set the high-intensity runway lights on medium intensity, the pilot should click the microphone 7 times, and then click it A. 1 time within 4 seconds. B. 3 times within 3 seconds. C. 5 times within 5 seconds. The correct answer is C. To adjust the intensity of the runway lights from high intensity to medium intensity, a pilot can use the radio microphone to transmit a specific pattern of clicks. The procedure typically involves clicking the microphone a certain number of times within a specified time frame. In this case, the correct procedure is to click the microphone 7 times, and then click it an additional 5 times within a 5-second period. This pattern of clicks is recognized by the air traffic control, ATC, or the lighting control system at the airport, triggering the desired change in intensity from high to medium. It's important for pilots to adhere to the specified pattern and timing of clicks to ensure the correct adjustment of the runway lights. This helps provide the appropriate lighting conditions for aircraft operations and ensures the visibility required for safe takeoffs, landings, and taxiing. 3770. A lighted heliport may be identified by A. Green, yellow, and white rotating beacon. B. Flashing yellow light. C. Blue lighted square landing area. The correct answer is A. A lighted heliport can be identified by the presence of a green, yellow, and white rotating beacon. The rotating beacon is typically installed on top of a structure or pole at the heliport and emits light that rotates in a circular pattern. The specific colors of the rotating beacon help pilots visually recognize and identify the heliport. The green, yellow, and white combination is commonly used to designate a heliport with lighting. The green color indicates the location of the heliport, the yellow color provides a cautionary signal, and the white color enhances visibility. The rotating beacon serves as a visual reference for pilots, especially during nighttime operations or when visibility is reduced. It helps pilots locate the heliport and distinguish it from other surrounding structures or lighting installations. Additionally, the rotating beacon also aids in alerting other aircraft and personnel in the vicinity of the presence of a heliport. It acts as a visual warning to ensure safe operations and to prevent any potential conflicts or hazards. 3771. A military air station can be identified by a rotating beacon that emits A. White and green alternating flashes. B. Two quick white flashes between green flashes. C. Green, yellow, and white flashes. The correct answer is B. A rotating beacon at a military air station is designed to emit specific light patterns to aid in its identification. The light pattern of the rotating beacon consists of two quick white flashes followed by a series of green flashes. The purpose of this distinctive light pattern is to differentiate the rotating beacon of a military air station from those of other types of airports or heliports. The two quick white flashes followed by green flashes help pilots visually recognize and identify the military air station. By observing the unique light pattern, pilots can identify that the facility is a military air station and take appropriate actions or follow specific procedures as required. This identification is important for navigation and communication purposes, allowing pilots to accurately locate and differentiate military air stations from other types of airports or heliports in the vicinity.